Today we're going to talk about synthetic division. But before we do, let's do a review problem and see if we can make any connection to long polynomial division compared to the synthetic division. What we do is we're going to take our polynomial of 2x cubed plus 5x squared plus 4x minus 4. We are going to divide by x minus 2. And when we divide by x minus 2, I'm going to go over into this space here where it says solve using synthetic division, and then I'm going to erase it. I think that you have enough space to put this work in on your paper. I just don't have it up here on my board. And what we're going to do is we're going to take this 2x cubed and we're going to divide it by x here. And maybe we are, and maybe we aren't. 2x cubed divided by x. And worst comes to worst, we have to write this out as 2x divided by x. And the x's cancel out. And we get 2x squared. And it's 2x squared times x, which is 2x cubed. 2x squared times negative 2 is negative 4x squared. Change both sides. And the 2x cubes cancel out. And then we have 5x squared plus 4x squared, which is 9x squared. Bring down the 4x. And then we're going to go through that process again. We want to get rid of the 9x squared. So we're going to take 9x squared. And we're going to divide by that yellow x. Worst comes to worst. We're going to go 9x divided by x. And our x's canceled out. And we're left with plus 9x as part of our quotient. 9x times x is 9x squared. 9x times negative 2 is negative 18x. Change both signs. And once again, when we change both signs, what happens, we have 9x squared minus 9x squared, which the 9x squareds cancel out. And now we have 4x plus 18x, which is 22x. And we're going to bring down the minus 4 or the negative 4, depending on how you look at it. And we want to get rid of the 22x. So we're going to take 22x divided by x. And what happens is positive 22x divided by x is positive 22. And 22 times x is 22x. 22 times negative 2 is negative 44. Change both signs. And the 22x's cancel out. Negative 4 plus 44 is 40. And we can't divide 40 by x. So 40 is the remainder. And it happens to be a positive 40. So our remainder is going to be plus 40 divided by x minus 2. Well, I'm going to erase this stuff in the box here, and we'll come back to the box momentarily. But there's another way that we can divide this problem called synthetic division. And synthetic division is a simpler process. Sometimes I call it the shortcut division. It's a simpler process for dividing a polynomial which means many terms, by a binomial. Binomial is like bicycle. There's two wheels on a bicycle, and there's two terms in a binomial. But synthetic division is limited. Long division you can use any, but synthetic is limited. Synthetic division is in the format, in order to use synthetic division, the divisor, what you're dividing by, has to be in the format of x minus some number or x plus some number. There cannot be a number in front of the x. We just call it a 1. The other thing is that the dividend, what we're dividing, has to be in descending order, and that's not a surprise. So standard form, and also, if we're missing terms, we need to put zeros in for those terms. So if we go back up here to the box, here's how synthetic division works. We're going to start by making an upside down division bar, and you need 2 notebook lines. Long division works based on variables. Synthetic division works with the numbers. So in our original problem, we start with 2x cubed, so this is going to be a 2. Then it's plus 5x squared, so we're going to write plus 5. Plus 4x, so we're going to write plus 4. And minus 4 is what we'll also write. We were in descending order. We're dividing by x minus 2, but to avoid change both signs, change both signs, change both signs, we're going to change the sign now. Since it's x minus 2 for our divisor, we're going to put a positive 2 out there. We're going to carry down the first term. We do that every single time. And now we're going to multiply. 2 times 2 is 4. 5 plus 4 is 9. It's positive 5 plus positive 4 is positive 9. 2 times 9 is 18. 4 plus 18 is 22. 2 times 22 is 44. Negative 4 plus 44 is 40. Do you see what just happened there? 2, 9, 22, and 40 are the same numbers that we have over there in the long division, in the same order, in fact. So the final step for synthetic division is that we need to put the variable back into the problem. And the other piece about the synthetic division is this. When we start with our polynomial, in this case we started and it was an x cubed. When we use synthetic division, what happens is our degree decreases by 1. So we started with x cubed, we divided, this is going to be an x squared. So when we put this back in, we're going to have 2, and then it's going to be x squared, then we descend. It's going to be plus 9x. Second degree, first degree, here's a constant, which means that this last part is going to be plus 40, our remainder, and then it's still going to be divided by x minus 2. we look at our first real example down here, use synthetic division to divide the following polynomials, write the remainder in simplest fraction form. Well, once again, when we start this, upside down division bar, leave enough space. So inside that division bar, you want 2 notebook lines worth of writing. Because our first line is going to be 5, the number in front of the x cubed, minus 2, the number in front of the x squared, plus 5, plus 2. That second 5 was in front of the x, and then the plus 2 was the constant. We're dividing by x minus 4. So what we're going to do is we're going to change the sign right now. Minus 4 is going to become positive 4. And then we're going to carry down the 5. Multiply. Positive 4 times positive 5 is positive 20. Negative 2 plus 20 is 18. Positive 4 times 18 is 72. 5 plus 72 is 77. Again, positive 5 plus 72 is positive 77. 4 times 77 is 308. And 2 plus 308 is 310. We started with x cubed. Whenever we synthetically divide, we decrease the power by 1. So down here, when we finish that, it's going to be an x squared. So when we fill the variables back in, we get 5x squared. And then we descend. Plus 18x. Second degree, now first degree. Plus 77. 0 degree. Which means that that last number of 310 is going to be the remainder. It's 310 over x minus 4. Is the divisor a factor? No. We have a remainder. It's not a factor. Again, upside down division bar. Writing the coefficients. Number in front of the x fourth is 1. Plus 2, the number in front of the x cubed. Plus 1, the number in front of the x squared. Minus 4, the number in front of the x. Minus 12. We're dividing by x plus 2. But in order to avoid the changeable signs, we're going to make this negative 2. Since it was plus 2, we're turning it into negative 2. Minus 2, whichever way you want to look at it. Bring down the first term. Negative 2 times 1 is negative 2. 2 minus 2 is 0. I'm going to write plus 0. There's nothing wrong with writing minus 0. Negative 2 times 0 is 0. And 1 plus 0 is 1. Negative 2 times 1 is negative 2. Negative 4 minus 2 is negative 6. And negative 2 times negative 6 is positive 12. And negative 12 plus 12, again, I'm going to write positive 0. This time, we started with x to the 4th. Our answer, our quotient, is going to be 1 degree less than what we started with. We started with x to the 4th, so this is going to be x cubed. going to be 1x cubed plus 0 x squared plus 1x minus 6, if you prefer, x cubed plus x minus 6. We don't have to write the 0x squared, but what I want to point out is that our answer needs to descend 3, 2, 1, 0. So either one of those formats is fine. Our last question here is x plus 2 a divisor? Sorry, is x plus 2 the divisor a factor of our polynomial? And we don't have a remainder, so it is. As we flip our paper over, the other thing that we need to remember is if we are missing a term, we need to fill in a 0 for that. So when we set this up, it's 3 plus 1. We don't have a first degree. So let's write plus 0 if you prefer. Write minus 0. And minus 4. 3 is the third degree. 1 is the second degree. 0 is the first degree. Negative 4 is the constant. We're dividing by x minus 1, so we're going to change that sign, and then we don't have to worry about the signs anymore. So minus 1 became plus. And we're going to carry down the 3. 1 times 3 is 3. 1 plus 3 is 4. 1 times 4 is 4. 0 plus 4 is 4. 1 times 4 is 4. Negative 4 plus 4 is 0. And once we do the division, we need to put our variables back into the problem. We started with x cubed, which means we're going to finish with x squared. So we have 3 x squared, and then we descend, plus 4x plus 4. We ended with 0. So is our divisor a factor? Yes, because the 0 is where the remainder would be. So x minus 1 is a factor. Biggest mistake that students make is forgetting to put the zeros in when we're missing a term. Second biggest mistake is forgetting to change the sign when we have x minus 1. We're going to divide by 1. But hopefully we've stressed those ideas here so that you don't get put into that situation. As we take a look at this last one, start with our upside down division. We are missing some terms, but the number in front of the x cubed is a 1. We don't have an x squared term, so we're going to put plus 0. We don't have an x to the first term, so we're going to put 0. We do have a constant. Now we've accounted for every place value. Third degree, second degree, first degree, 0 degree. We're going to divide by, we are divided by x minus 4. So we're going to change the sign out there. And then we don't have to worry about signs anymore. We're going to multiply. 4 times 1 is 4. 0 plus 4 is 4. 4 times 4 is 16. 0 plus 16 is 16. And 4 times 16 is 64. And negative 8 plus 64 is 56. And we're going to put our exponents back in, our variables back in. We started with x cubed, which means we're going to finish with x squared. This is going to be 1x squared plus 4x descending plus 16 plus 56 divided by x minus 4. Is x minus 4 a factor of our polynomial? No. We have a remainder. It is not a factor.